So our next speaker is Umer Huzaifa from UIUC.
Okay, hello everyone. I'm Umer from University of Illinois, and I'll be talking about our work on stylistic gaits using core located actuation. So the inspiration for our work comes from Bartiniev's Basic 6. Bartiniev's Basic 6 is a set of exercises that is used for rehabilitation of people with immobility, especially polio patients. Now, what these exercises dictate is that human walking is majorly played by the pelvic shift laterally and in the sagittal direction. And thigh lift or the legs actually play as a support for this shifting. So, and in biomechanics literature, use of word core is also used in place of most of the pelvic muscles. So I'll be using core in place of pelvis later on as well. So what we've done is we've taken inspiration from these exercises, these 3 exercises, and developed a model that has a major mass shift on top of the legs. So this is a very simple model, 2 stick legs and a mass on top of it, which can be translated in the sagittal direction. And you can, there's a force actuator that can control the displacement dt. We have assumed that the mass can only move perpendicular to the hip, so I'm only considering the sagittal movement. And for the purpose of gait design, we're assuming 3 gait parameters. 2 of these parameters are assuming are connected to the idea of forward pelvic shift. So CD shape is defining which desired gait waveform dt is following, and CD max decides how much maximum distance can dt go in either direction. And TL is related to the step length of the biped. For gait design, you're using these gait parameters in trajectory optimization to come up with a gait for a single step. And I'm using these gait parameters to define path constraints on the paths dt. So I'm basically trying to track that defined waveform. And TL is just defining the step length for the model. And I'm not really minimizing a particular cost function. I'm just looking for a trajectory that satisfies these constraints. So for most of the values, I'm just assuming a constant cost function. I just want to satisfy the constraints. This formulation is helpful because by varying these gait parameters in a particular range, I can get a lot of different gaits. And among these gaits, sorry. This is stuck. Okay, so among these gaits, we have taken help of a certified movement analyst to pick a set of 6 gaits that can be related to humans, human walking experience. And we've identified that there are these 6 gaits that can describe some human walking behaviors. And to validate these gait labels, we have conducted a user study where we've asked lay human viewers to see the gaits and check if they agree with the gait labels. And most of the gait labels have, on average, got agreement from the participants. So in summary, we're exploring if core located actuation can help us with generating more variations in the gaits, and possibly gaits which are more meaningful to human viewers. And I would like to acknowledge my co-authors and collaborators. And that's it. I'll be happy to answer any questions. Sorry, what is the what?
What mechanism would a human use to move the center of mass back and forth?
A human is using, so we're hypothesizing that probably there's some action of pelvic muscles. In some way, they are playing the part in shuffling. So they're executing a major shift of center of mass, and somehow legs support that shift and keep that stable. We're hypothesizing, I think.
I was just maybe I missed it, but I did not catch the part that led to your conclusion or contextualized your conclusion that these are more meaningful, I guess, to a human. And
yes.
Why is it important for a human to distinguish or interpret these particular gaits that you've developed, or this level of variation among them?
The main goal for this was to have robots with different gait styles, so robots should have these options, and so that if in future if robots might need to be more expressive, they can express some emotions or some expressions using these set of different options. So we just wanted to check if we just wanted to make sure that we're not just randomly assigning gait labels to things, but a lay human viewer could also see the value of the gait label and could agree to some sense to those gait labels. Does that kind of answer your question?